On August 15, 1977, Ohio State University's radio telescope detected a powerful 72-second anomaly. Decades later, the "wow" signal remains our most compelling, yet unverified, candidate for an extraterrestrial transmission. At the time, the observatory's SETI project processed vast amounts of information using IBM 1130 computers. Astronomers had to review the continuous paper printouts by hand to spot any irregularities. This diagram shows the radio frequency spectrum, focusing on 1420 MHz. This is the exact frequency naturally emitted by hydrogen, the universe's most abundant element. Physicists theorized any advanced civilization attempting interstellar communication would select this recognized frequency. The 1977 detection registered on the exact bandwidth where science had hypothesized an intelligent species would try to make contact. Looking at a reproduction of the original data column, the famous string 6EQU5 is often mistaken for a decoded message. It is actually an alphanumeric scale recording the signal's intensity averaged over 10-second intervals. This graph plots that alphanumeric sequence. Numbers 1 through 9 track low intensities, while letters indicate extreme spikes. The peak character U represents a surge 30 standard deviations above normal background noise. The entire sequence lasted exactly 72 seconds. Because the telescope was fixed, relying on the Earth's rotation to scan the sky, a continuous point source in deep space would register for exactly that duration, peaking at the center of the window before fading. The signal originated from the direction of the Sagittarius constellation. However, the telescope utilized twin feed horns, creating a spatial ambiguity. It is impossible to determine which of these two specific narrow zones captured the transmission. A deep space origin point, a perfectly matched 72-second duration, and immense transmission power forced the scientific community to treat the event as a serious candidate for an artificial source. Despite more than 50 targeted follow-up searches pointing at those exact coordinates over the next several decades, the signal has never recurred. These null results persist even when deploying modern equipment, like the Very Large Array, which is significantly more sensitive than the original Ohio State telescope. The strict rules of the scientific method require replication for confirmation. A single isolated anomaly lacks the evidentiary weight to be definitively classified as a technosignature. Recent astrophysical research points to rare natural explanations. One leading model suggests a cold hydrogen cloud, suddenly energized by stellar emissions, could surge in brightness and mimic the exact profile recorded. While the evidence now points toward an exceptionally rare natural phenomenon, that 72-second recording remains the defining historical catalyst for humanity's search for extraterrestrial intelligence.